Hello, everyone. Today we'll talk about potato disease classification using conventional neural network. This is being done for data science project presented to Dr. Zulsaniyati Binti Marjudi. Um, introducing before we dive into the project, introducing my group one. Our names are Sabri Nasir, Muhammad Fuad, Muhammad Ibrahim, Ahmad Mukhtar, Hussam Rajab, and finally me, Ruknuddin Muhammad. So let's have an introduction before we dive into the into the project. So for farmers agriculture researchers, classifying plant disease is an important responsibility, and accurately identifying and categorizing plant disease may help limit the spread of the dangerous, very dangerous, but uh, so boost crop yields and eventually enhance the general productivity and health of agriculture system. But however, conventional techniques are for classifying plant disease, including human examination for microscopy, may be labor, and the time is very intense. Recent development in computer vision and machine learning have made it visible to identify plant disease using conventional neural network. To make it more simple, the deep learning system known as CNN is extremely effective at classifying images. They are made up of several layers and linked neuters that have been taught to spot patterns in pictures. Higher levels oversee detecting more complicated patterns such as forms and objects, while lower layers observe basic patterns such as edges. The layers of Neurosyn in CNN are placed in in the hierarchical structure of the capacity of the CNN that automatically learn characteristics. From photos is one of its main advantages for classifying plant disease. Traditionally, professionals must manually recognize and extract information from photos to classify those plant diseases. However, CNS can automatically learn characteristics from pictures, reducing the requirements for human specialist and improving classification accuracy. Now I'll pass to my classmate to continue with the problem statement.
Hello everyone, and I'm going to continue with problem statement. A critical issue in agriculture is the categorization of plant disease using deep learning. Plant elements have the potential to significantly reduce agricultural output and cost farmers a lot of money. For the purpose of managing and avoiding outbreaks, it's critical to identify the categorize these elements swiftly and precisely. Deep learning is an effective method for classifying image and has been used effectively in a variety of fields, such as object identification and medical imaging. Deep learning may be used to evaluate pictures of disease, validate and correctly identify the particular illness that is present in the case of classifying plant disease. So the goal of this kind of study is to create a deep learning method that can correctly categorize virus plant disease using picture of infected leaves. This model should be able to generalize to new unseen photos after being trained on a dataset of tagged photographs of airplanes. Lastly, the objective is to increase the effectively and precision of disease detection in agriculture, assisting farmers in successfully respond to disease outbreaks in their crops. So I will pass to my classmate to continue.
Now I am going to continue with the data set. In general, the data plant village data set is commonly used for classifying plant disease using deep learning. This collection includes about 54,000 photos of damaged and healthy plant leaves taken from several plant spe- uh, species. It is significant resource for training and associating models for blind disease classification. Since the photos are annotated with the 38 distinct disease categories. A term of research from Penn State University and the International Institute of Tropical Agriculture in Collaboration with several other organizations complete the Plant Village dataset. Continue. The Plant Village dataset is a great and extensively used resource for classifying plant disease using deep learning. It includes a bird and representative sample of plant analysis from various group species, making an appropriate dataset for training and associating classification algorithms for plant disease. And we have customized the Plant Village dataset to 900 images due to the lack of computational power that would be needed if we try using the original size dataset. We're going to need a huge computational power, so we redirected it to the minimal size to suit our valuable resource. And the general description to the application domain of the dataset. The primary application domains for the plant village dataset are agriculture and planet pathology. The dataset is intended for use the deep learning algorithm for the categorization of plant disease. And in the second, the collection comprises photos of damaged and healthy plants from several type making it applicable to the broad range of agriculture applications. And the third, the creation of computer vision models for the automated detection and classification of plant disease is one of the primary uses of the dataset. And this the dataset attribute. We have three classes we implemented with the potato classification. The first class is potato early blight, and the second one is potato late blight, and the third one potato healthy. And my friend will continue the methodology.
So the methodology for this project, in this project, the convolutional neural network will be used as algorithm to implement the planet disease classification model. So the CNN are a type of feed-forward artificial neural network that are particularly well suited for the image classification tasks, and it have been widely used in many computer vision applications, including the object recognition and image segmentation. They consist of multiple layers of artificial neurons that process the input image that are a series of computationals, and they are Boolean and fully connected layers. The computational layers are used to extract the pictures from the input image by applying a set of filters to the image. So here is the pieces of developing the CNN model. So we start with data gathering and primarily processing. So next step or next phase is to pre-process those images. And during the pre-processing step, we need to do scaling the photos and translating them to the standard format and normalize the pixels value. So after that, the next step is to extract the features from those selected images. And the second phase is the machine learning model will be trained to categorize the photos based on the retrieved features. The next step is the model evaluation. During the model evaluation, the performance measures using a distinct dataset. This includes evaluating the model ability to accurately identify the pictures using measures like accuracy, perceptions, and recall. Last phase is to deploy the model in a particular application such as smartphone apps or web applications to assist the farmers in the field with diagnosing the plant illnesses. So the implementation of the CNN model. So we start Firstly, we start with importing the necessary libraries for implementing this code. Secondly, we need to load our dataset. As we can see here in this model, this code show the TensorFlow Keras processing the image dataset from the directory that is specified where we save our dataset. And after loading the dataset, the function it will extract the arguments and the images from the dataset. As we can see here, the output of this function is it will find out and it will load the dataset, which we can see here. We have 900 images inside three classes. So the second function here, we have the function called class name, and this one will extract the class's name labeled inside the dataset. As we can see here, the output of this function, we have the three class, it return the three classes, the potato, early play. This is the first class, and the second class is the potato with late play, and the third one is the potato healthy leaves. And here is a sample of images of the dataset. Each figure here display a grade of 12 photos from the dataset in the first batch. As we can see here, this is the potato leaves on healthy condition, and then this one is on late plate, and this image here shows the potato with early plate. So the training and validation accuracy. The training and validation accuracy over the number of epochs as shown in this graph here. It shows the first subplot while training and evaluation the loss over some numbers of epochs during the training for this model. As we can see here from this graph, we can illustrate that the accuracy on the training accuracy, it starts very low and then it increased with more epochs. It increased until it reached close to 100% accuracy. And then the validation accuracy as well, it start very low, like 65%, and then it increased until it's close to 100% accuracy. On the other side, we have here the training and validation loss. We on the first we start the model when it start training and learning. We can see here like close to 100% loss, and then it decrease until we reach the minimum of zero losses for the training and the validation loss. And here is the output of our model. As we can see here, for example, this image, the actual class that was initiated for this image was the potato on healthy condition. And the predicted class is the potato with healthy condition. As we can see here, the leaves is doesn't have any damage. On the other side, we can see here this one, the classification for this picture, it was potato with late plate, and the predicted class from our model, I mean the result of our model, it classify it as a potato with late plate, and this is like 100% accurate. So we came to the end with the conclusion. In conclusion, the categorization of plant disease using deep learning is a significant job in the world of agriculture since it enables the farmers to respond swiftly and effectively to crop disease outbreak. The Planet Village dataset is a great and commonly used resource for this job since it provides a broad and representative sample of plant disease from various crop species. The convolutional neural network (CNN) are good in classifying the plant disease, And the CNN algorithm will be suited for this purpose since it can successfully extract the characteristics from photos and categorize them. And the data collection and pre-processing feature extraction, model training, model assessment, the model deployment are component of the approach for creating planet disease classification model. The model can be used in a particular applications such as smartphone apps and web applications to assist the farmers on the field with diagnosing the plant illnesses. This may enhance this may enhance efficiently and accuracy of the disease identification in the agriculture, resulting in higher yield and less financial losses for the farmers. So that was all from me and my group, Group 1. Thank you so much.